Okay, so section 4.2 got trig functions in the unit circle. Hopefully you've already watched the PowerPoint video for this, and we know that this portion of the triangle is just the 45, 45, 90. Typically, you're going to see all of the markers in the circle though. So if we take a look at this guy, then we know we have different color coding from the previous video. If color coding helps you, I highly recommend making it consistent throughout the problems. So if we go through with this, then notice that with, I think it was the 45s that we had green on these for the X and Y axes, so the 90 degrees. And then we went through and we had yellow on the 45s, so on those guys there. And if we take a look at the next one, which is just further down your paper, then we know that we also have the other ones here that showed up as blue for us. So we've got our pi over 6s right here that are blue, and then this pi over 3, which is blue. So we went through, and this is just the same color coding from before. So if color coding helps you, great, go ahead and do it. These are the exact same things that we've done previously. Now let's actually take a look at how we go through and find the 6 different trig ratios based off of a location. So just as a quick reminder, when we go through and we identify the different quadrants, we always identify them the exact same way. So we know this is quadrant 1, and then we go counterclockwise. This is quadrant 2, this is quadrant 3, this is quadrant 4. And we still have the ASTC that was brought up in the previous. So we know that in quadrant 1, all of the trig is positive because the combination of points or values is positive, positive. And then we've got sine and its reciprocal is going to be positive in quadrant 2. And then tangent and its reciprocal positive in quadrant 3. And then cosine and its reciprocal positive in quadrant 4. So all stuff that we've already seen before. So let's take a look at actually using the stuff that we've done. So I'm going to take out my coordinate plane, and I would draw this circle, but it's not really necessary. Like, I already know and can imagine a circle that is going to have a radius of 1 that is centered at the origin. So if it helps you to draw the circle, draw the circle. It doesn't matter how big or how small you draw it, or you can just leave the regular coordinate plane if you want to think about it that way. So since I've got a circle here, I'll go ahead and just stick with it. Okay, so what I want to do is I want to start on the initial side for all of my angles. It looks like I'm going negative, so I'm going to go down, and then I need to go 3 pi over 2. Okay, so if I go all the way over here, that's 1 pi. If I keep going, I'm going to land at negative 3 pi over 2 here. Okay, so negative 3 pi over 2 is the exact same location or coterminal with pi over 2. And then I know this point up here at the top is going to be 0, 1. Remember, as we've already talked about, that the x value is going to be cosine and that the y value is going to be sine. Okay, so we can actually just go ahead and add those in. So cosine, I'm going to go ahead and just put in 0. And for sine, I'm just going to go ahead and put in 1. And then we know that tangent itself is y over x, which we could also say is sine over cosine. So we can take our two values here. So my sine value was 1, my cosine value is 0. I can't divide by 0, so this is undefined. Once I know the first 3, it should be good, and I think I can find the other ones. So remember, for sine to cosecant, so if I have cosecant, this is going to be 1 over sine, and I'm not going to write this every time. I'm just going to take my sine ratio, and I'm going to flip it over. So whatever I got for sine, I'm just putting in the bottom. If there's nothing in the top of a fraction, put a 1. So it looks like cosecant's just going to be 1. For secant, I'm going to do 1 over cosine. So I'm going to take my cosine value, put it in the bottom, put a 1 in the top. This is going to be undefined. For cotangent, okay, now this one's a little tricky. Tangent itself was 1 over 0. So if I go back to the work that I did, if I take my tangent and I flip it over, so this is 1 over tangent, then this is going to give me, just flip this guy over, 0 over 1, which is 0. And then the last thing I have with this cotangent, 90 minus theta, or pi over 2 minus theta, these are my complementary co-functions. This is going to be the same thing as tangent, which we already determined is undefined. Then we're just going to keep moving on. So why don't you pause it, see if you can sketch the location of 19 pi over 6. Remember, all of the pi over 6s are kind of like, they're the not tall triangles. So they're super close to the x-axis. And then the pi over 3s are the tall triangles. Those are the ones that are close to the y-axis. So why don't you pause it and see if you can figure out where 19 pi over 6 is, and then we can start evaluating. So when I went through and sketched this, I was like, I know that that's past a full rotation. So I took the rotation out. So I subtracted 2 pi, found a positive coterminal angle, figure out where I was supposed to land. And it ended up that I was supposed to be at 7 pi over 6. And so I know this radian is going to be 7 pi over 6, so going out that. And then I wrote my coordinates at the very end. So negative root 3 over 2, negative half. Okay, the exact same thing. I know that the x value is cosine and the y value is sine, so I can go ahead and fill those in. So cosine is going to give me negative root 3 over 2, and I know sine is going to give me negative half. Now, I can still do tangent, so let's do tangent is equal to sine over cosine. So it's going to give me negative half over negative root 3 over 2. When you have a fraction divided by a fraction and both of the denominators are the same, we know that we would multiply by the reciprocal. They cancel. The 2's are gone. So this is going to give me a negative divided by a negative, which is a positive, over root 3. I got to clean that up. So this is going to give me root 3 over 3. Let's go ahead and plug that in for tangent. And then I'm just going to go back and do the same thing that I did before. I'm going to take my cosine and I'm going to flip it. That's going to give me negative 2. I'm going to take, my sine and flip it. I'm going to take my cosine and flip it. Okay, I might need to do some work for this one. So if I want to do secant, secant's going to be 1 over cosine, or just the reciprocal of cosine. So I'm going to take my negative root 3 over 2 and just turn it into 2 over negative root 3, multiply by root 3. That's going to give me negative 2 root 3 over 3. So if you don't have them memorized, you can always go through and find them. Negative 2 root 3 over 3. Cotangent, I'm just going to go back to any stage of tangent that I want and flip it over. And I think I'm going to take that one in green. If I can take 1 over root 3 and flip it over, that's just going to be root 3. And then for secant, these are the complementary co-functions. So I'm looking for cosecant of theta, and I can just grab that answer. That's negative 2. And then I highly recommend just doing a quick check on this. If you are in, so which quadrant are we in here? This is A, S, this is the T quadrant. So if I take a look back at my answers, the only ones that should be positive are the tangent and cotangent. Everybody else is negative. Okay, let's take a look at, well, we've got another one very similar to this. So why don't you pause and see if you can do all of the one for 11 pi over 6. Now, since it's still a reference of a pi over 6 angle, you still have the same combination of side lengths. It's just which one's positive and which one's negative. So if I take a look at this, I am in the ASTC quadrant, which means I should be looking for cosine and secant being positive. Every other answer that isn't related to either cosine or secant is going to be negative. Okay, 675 degrees. Don't need to convert. I do see that this is well past a full spin of 360, so I'm just going to cut out a couple of 360s until I figure out where I land. So if I take 360 out of this degrees, if it was radians, I would take out a 2 pi. This is going to give me 315 degrees. Okay, if you're comfortable where 315 degrees is, then go ahead and graph that. I know it's really close to another 360, so I am going to subtract another 360 because it's close. I just want to know how close. Okay, this is the same as negative 45 degrees. So I'm going to go ahead and figure out where negative 45 would land. So I know where negative 45 is going to be. It's going to be right there. And really, unless it says draw the angle, I don't really need you to draw it. I just need you to tell me what the trig is. So the directions did not say draw the angle and then. So I just need to know that this is the same as negative pi over 4 and that that location is root 2 over 2, negative root 2 over 2. Remember, the first one's cosine, the second one is sine. Be careful with your angles. See if you can fill in all of them. Figure out that I am in the C quadrant, which means cosine and its reciprocal are the only ones that should be positive. Everybody else should be negative. Okay, the last thing we have in this section is even and odd functions. We talked about even and odd functions first semester when we did pre-calculus, and it had to do with symmetry. So if you have an even function is symmetric, so let's say even, is symmetric to the y-axis. So first semester we talked about like parabolas, symmetric to the y-axis. Then if we had odd functions, this means that they were symmetric to the origin. And this still follows. So symmetric to the origin. So a cubic. So then you have like a point up here and a point down here. They have the exact same values. It's just the combination of the positive and the negative signs. And then back in the even, it's like stuff on the left and stuff on the right have the exact same values, but the only difference is the signs. We have the exact same thing here when we're talking about trig. So let's use, I don't know, theta is equal to pi over 4 as an example. So if I do pi over 4, let's say I'm going to do cosine of pi over 4. Okay, now I know cosine of pi over 4 is root 2 over 2. Like I know that. So if I take out my little picture here, I know pi over 4 is up there. If something is an even function, if I flip the sign on the angle, so now I'm going down to negative pi over 4. Notice that the cosine value, which is the x, that hasn't changed. This is still root 2 over 2. So basically what we're saying is if it's an even function, which cosine is that cosine of the angle, whatever it is, or radian, and cosine of its negative counterpart are the same. That's because the x side of the triangle that relates them hasn't changed. Whereas if we take a look at sine, so let's say I have sine of pi over 4. Sine of pi over 4 I know is root 2 over 2. So I might take out that. I know pi over 4 is up here. But we're taking a look at the y value of this. So there's the y value right there. Notice that we're going up, which is why it's positive. If I take a look at sine of negative pi over 4, so I go down negative pi over 4, the length is still the same. It's just now I'm going down. So this one's down, that one's up. So I get negative root 2 over 2. Basically what it says is if you take sine of the negative angle, it's going to be almost identical to sine of the positive angle, except the sign is flipped. Okay, so our even and odd functions are defined here, and then the definition off to the side also for odd being sine, cosecant, tangent, and cotangent. But you can go through and establish that using a radian inside the unit circle. Okay, so now given, so we're going to use what we know about even and odd functions. So as soon as you see this like cosine of a negative angle, you're being asked even odd. That's what this is saying. So if I have cosine of theta, because it is an even function, they're the same. Which means if I want to find cosine of negative theta, I plug in what cosine of positive theta is, and I have my answer. So cosine of negative theta is still going to be 1/4 because the x value hasn't changed. Okay, cosecant of negative theta. Okay, this negative, we're being asked even odd. That's what this is saying. Okay, well, cosecant is an odd function, which means if you take cosecant of the positive angle, you have to flip the sign on it. So plug in what I know. I was given that this is -7/4, and then divide by that -1 that's right there, or flip the sign. So this is going to be 7/4 is equal to cosecant of theta.